So we're going to talk about package management. Eli kind of talked about before, this is one of the advantages of Jupyter Hub, is that it takes your job from system administrator to scientist, right? I think Eli are both and I are both of the vintage where those two were kind of hand in hand. You couldn't do a lot of science unless you knew far too much about system administration. But that's just how the work got done because this was early on in the age of computing. So in the beginning, everything was based on the file system. So you had generally running different flavors of Unix. Most of the Unices were all kind of similar, but they had different places where they tucked away different bits and pieces. And so if you were running on a Sun Microsystems system, for example, it was /sbin instead of bin, or they had all these different naming conventions. But eventually Linux came along and everyone just started using Linux. And so a lot of those problems went away. So at least the Unix file system was relatively the same. Different variant of Linux have different file systems. But all of them kind of have this structure where there's a place where you have binary files. Those are programs that run. There's a home directory. That's like your Jupyter Hub home. That's where all your local files are. And then there's the lib directory, which has all the libraries for all the software you're running. If you guys use Unix all the time, this is old hat, and you've heard it before, so I'm sorry to bore you. But for those that are newer or don't use Unix, or mostly using other operating systems, for Windows, this is like not having a DLL, and in Macintosh is now all based on Unix, so it's not having the right library. But the program that you're trying to run won't run for some reason. That's because your dependencies are in those libraries. And Python has the same set of dependency nastiness that Unix does, insofar as when you install stuff in Python, you need some cool package, is awesome, but it requires a bunch of other packages that that person didn't develop, but built on top of their packages, right? So Python has a very complicated ecosystem of different things that let it run. And this is a graphic that I liked a lot, which shows different ways that you might install some of these packages depending on your operating system, and it's a big, ugly mess. And if you haven't ever run into this problem, you're lucky, and God bless you, and you're probably using Conda or some other package manager already. If you have run into it, then you know what I'm talking about. So package management developed as an automated way to manage all of these dependencies into one central framework of like, I want to be in this environment running this set of code in this way, and it all keeps everything consistent, more or less. There are a bunch of different ways to do it, of course. There's the old standby, and the best is the oldest and most effective has been called Conda, and it is a way to manage all of these packages. If you've ever used the command conda install blah, that's what conda is. It's managing those packages for you. There is something called Mamba, which is a lightweight conda. It's not quite as complex. It's a little bit faster. So if you have a lot of packages, I'm guessing, Eli, you're judging from your file directory, you have a lot of packages. It can take a long time, just like starting up the server. It just takes a long time to get what you want to do. And now Alex last year introduced me to Pixi, and I hadn't known about it before. Pixi is yet another way to manage your packages. It has some specifics that make it very nice. That I'm going to talk about. Again, this is all for managing Python dependencies. R has a similar, you must have a package manager in R too, is that right?
It works totally differently.
Okay.
We exist under a benevolent dictatorship.
Benevolent dictatorship is always good for productivity, unless you want to do something different. But okay, fine. So the important trick for this demo that I'm going to do is, like, I was working it out last night, and that's where we discovered we had some issues, but picking the OceanHackWeek kernel for your Jupyter hub will be important if you're going to follow along. You don't have to follow along. This is more just sort of a conceptual, like how things work. And I think through the week, if you're using that and you want to use Pixi, just pull me or Alex aside and ask questions. It'll be easier to work through the details. But now we're going to go to the live demo. So I have two. This is the reason that we have things. I'm going to show why this is important. Okay, so I have a bunch of code here in this notebook. And I set myself a little reminder. This won't work unless you follow the instructions. But I'm going to try to execute this cell here, which imports a bunch of packages, right? We import more to packages. Basically, I want to make a range ring, which was give it a latitude and longitude and then calculate a 1,000-kilometer range ring around it. And then send that back to me. That's what this function does. And then it fails because it doesn't have this KML. This was also to put it into a KMC file so I can look at it in Google Earth. Okay, so this is the first step in your journey where you realize you're going to install some cool package and then you're going to get this error, no module, and you're like, oh, I got to install this thing. In the old days, you have to go like download the package, compile it, if it was in C, but in Python, you have to install it in the right spot, blah, 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 blah. These days, most people just use conda install package and restart and everything works. It's magic. It can get pretty complex, but in any case, this is the problem we're trying to solve. So I'm going to go here to launch. If you're using Pixi, Pixi is a little bit different than conda. One of the things that conda does is it has this concept of environments where you can create an environment that has all the packages you want in that environment. And then you run your code inside that environment. And it works very well. The challenge that you run into is sometimes people don't document their environment very well. And so if you download a GitHub repo of code and you run it, sometimes the people who made that repository forget to tell you, oh yeah, you need this simple KML package. I forgot to put that in the environment file for my conda. And then you got to figure it out, right? So it's not the end of the world, but it takes some figuring out. Pixi is a little different in that it installs all of the dependencies directly in your repo. So you have it works only with a configuration file of all of the things, and then that gets saved in the repo, and then you run it from the repo that way, and it generally works, and you don't have this image problem that you can run into. Okay, stop me if I'm going too fast. Pixi. So this is the Pixi command. It's like the conda command. It's got a whole bunch of things to do, a whole bunch of versions, a bunch of information you can get out of it. Oh, come on. I gotta move this thing.
What's the advantage of Pixi over Conda?
So one of the advantages is it's a little bit faster and easier to solve for the dependency tree. And then the other, what I found in my work is that they're roughly comparable. But with Pixi, I know that in the working directory I'm in, that I will have the right environment if I'm using Pixi. A lot of my other work, I'll be like, oh, this code works in this environment, and then I'll be working over here and doing some other thing. I try to run the same stuff, and it fails, and then I got to go back and change environments and keep track of all that stuff. It's a pain. But Alex probably has more better reasons.
It's really when you're collaborating, like building the image for all the tutorials. We have all the tutorial authors saying, hey, I need X, Y, Z, and they're saying them all in separately. It makes sure that as new dependencies come in, it automatically includes all of those in the environment. So one thing I've seen often is, yes, there's an environment.yaml that someone's included in a repo with some manual install docs. when there's a new dependency added, hopefully someone adds it to that. But then actually telling people that there is a new dependency and that they need to reinstall the environment. Pixi checks that, what they call the manifest, pixi.toml, pyproject.toml. It checks it before you run any command. And if your environment is out of date, it brings it up to, it brings it into compliance. It brings it up to date. It'll install all the packages on the fly. It can solve the environment that fast.
And it's the collaboration piece is the really important part. So if there are two people working on the same code base and somebody's like, just what I did, you run into some issue and you're like, oh, I got to use this cool package. This is great. I install it. And you're moving fast, right? So you just keep developing. And then you check all your code in and then everything breaks.
And
So
one of the issues is often, even if someone kind of following the updates does remember to use their environment, if there is an issue, often it's really hard for them to debug that issue. Some of the choices that the Pixi team made pushes that on the back to the person installing the new package in the first place. You explicitly say like, hey, I want to run this environment on Macs, Linux, Windows, ARM processors, all those different types of platforms that it might work on. And Pixi will be very explicit, like, hey, it doesn't work there. Like, figure something else out. Don't make your teammate who doesn't understand this suffer later. Because usually the person installing is the one who's got the most understanding of the environment.
Eli?
Yeah, so when I'm working in a Conda environment, I'm speaking as somebody who doesn't use Pixi, but uses Conda a lot. So if I'm working in a Conda environment, let's say I have for each repo, GitHub repository, I have an environment YAML. And let's say I create my Conda environment. So so what would happen is that I would have a Conda environment, and then I'd have my Conda environment number 2. It would have all those packages. So there'd be a lot of duplication. So very, very soon my home directory might get massive. Does Pixi have that problem?
It does not. It uses a shared cache of packages. And it's very explicit when you add a package, it defines the one you added in one spot, but then all of its dependencies. So if you want to run Pixi tree.
Yeah, that was the next one I was going to do.
Okay. So it's rare that a package stands alone. They almost always depend on a whole lot of other stuff. So very explicitly, the green ones up here, or the top level of the tree, are the ones that we've added to the image. But then there's all the other dependencies. So Pixi records all of that for every platform you define it for. And then keeps those in a shared place on the system. And we'll reuse those if possible.
And it just points to those ones instead of you installing it multiple times. But we're getting ahead of ourselves before we even showed what it does. Yeah, go ahead.
I just have a general question. Does everyone understand the concept of Conda environment?
Thank you for asking that question.
I'm sure they don't.
Yes, I did not spend much time talking about that. Shame on me. But so the Conda environment is meant to simplify this picture, right? So if you have a program that has some requirement that you need it to run, Conda is a way to manage that dependency of that program on that library in a consistent way. And it basically creates other containers, they're not virtualized. It creates pointers to all of the dependencies you'll need to run that thing. It's a way to manage these things. So again, for those that aren't doing system administration all the time, it's sort of noise in the background, but it's really the reason that if you're on some system and you want to run some program and it doesn't work, the system administrator says, sorry, I can't upgrade that package because it will break the dependencies. You're gonna have to wait. So you have to wait to do all that. If you install Pixi, you might be able to do it on your own. But
So you have pure Python dependencies that are super easily installable via pip. And then Conda makes it so that you can install a lot of dependencies that depend on C or assembly code or Rust or a lot of other things that have been really traditionally hard to install via pip. Pip's been getting better over time, but Conda was the original solve made for the scientific applications. Pixi builds on top of both of those ecosystems and really makes them integrate together. So any Conda package you can install through Pixi. Any pip package you can install through Pixi, and it takes care of the interplay, a lot of interplay between the two.
yeah,
You said Pixi has like a shared cache of packages. Does that mean you have to be specific about what version of each package you use in each manifest? Or
No, you can find that as a range, and it'll find the best available.
yeah, it'll solve that for you, or you can specify it if you know the specification.
What if I need two different versions for two different projects? Does that work?
Yeah.
Yeah.
So in project 1, you have a Pixi description of everything that it depends on. Project 2, you have a different one. And both of those, where they share stuff, they would point to the shared cache. And where it's unique, they would have their own unique little pointer to where that package lives.
And it can do multiple environments in a single project. And those can overlap. They can have certain dependencies that apply to all of them, some that are specific for one environment versus the other. We take advantage of that system to help define this image so that we know, like, oh, we aren't doing this tutorial, you can just turn off that environment or those dependencies, and it won't be built into the whole image, but we can use them in the future.
So I think maybe some demonstration might make it a little bit easier. Remember, the motivating factor is this problem. I can't find the module simple KML. My code won't work because I need this package, simple KML, which is, as you might imagine, a simple KML writing package. I could write it out by hand, but somebody's already done all that. So I want to use this package. It's a lot easier. Pixi, it's run at the command line. Oh, shoot, that's not right. And that's what I've been doing here. I made the font small just so you can see all the dependencies. So in the OceanHackWeek image that we're using, these are all of the Python packages that are being run and their dependencies. If I just want to look at just the list, I do Pixi list, and this is a list of every Python package and other dependency that is installed in this image, right? There's a lot of them. Sadly, if I go down to S and look for simple KML, let's see, it's not there. Simpervisor, I don't know what that is. That sounds cool. But you can also do, what's that?
Figure out whose fault it is.
Yeah. We do that, and then we do a grep, so this works just like Unix. With the Unix tools, you can see it's not there, right? Okay, so we need to add it in. So in order to add that package in, I'm going to do a couple things. One is I'm not going to do it in my home directory. This is my home directory here. I'm going to make this bigger again. Oops, not that big. Somewhere like there. So these are the directories I have. And rather than having a Pixi environment for all of my projects, I want to do, somebody was said about different projects. So I'm going to make this its own little project and just manage the dependencies here for that thing. So I made this directory called package management test that has these notebooks in here. And then if I'm in this directory and I list, I still see all of them. If I do this, where I say Pixi list manifest path equals Pixi.
Manifest or manifest?
Good question. Oh, I guess that list doesn't work with that way, sorry.
You're on a different hub, so you don't have that.
Right, I just haven't initialized the directory here, so. So the first thing you do to use Pixi in a directory and make your own special set of things is to initialize it. This is like a conda init. It's comparable to a conda init, right? Maybe. It creates this TOML file that tracks stuff. So, ooh. Oh, good Lord. So now we have this TOML file here. And right now, there's not much listed. And it says no packages. Now I have no packages installed at all. And that's a problem. So well, the package I wanted to install was the simple KML, right? So I'm going to do Pixi Pixi add simple KML. And then on the hub, it's important to specify the TOML file that we want to use.
You don't need that anymore.
I don't? Oh,
That's what I was trying.
I just do this?
You can write Pixi
oh,
Yeah.
great. Thank you. You have 4 steps ahead of me, as usual. Sorry.
That's what I was trying to, I think, explain last night. I was falling asleep.
Yeah, I was done. So now this Pixi is going out and it's finding the package and it's seeing what dependencies it has and it's preparing all that stuff and then it's going to install them. This takes a little bit of time. But this is very similar. If you've ever used Conda, it's just basically doing the same thing. It's going to Conda Forge and saying, well, where is that thing? Pull it in. What does it require? And then it installs all the dependencies.
So are you still making Pixi environments for different projects, or is this like a catch-all for everything?
I generally, you can do it, I think, both ways, but I think if there is a Pixi file in that directory, in that repo, then it sort of takes over the description, right?
Yeah, you're generally making it per projects that you're working on, whereas con environments, you might build them upon like a theme. Here's my data science environment. Here's my environment for making random. Very specifically for that, and you work in that space.
Yeah, different ways to work.
So one comment kind of about this. So if you are, listening to this and you're thinking, oh my God, Eli, you just told me I didn't have to become an engineer and know how to install everything, and now we're talking about installing everything. So so at the Hack Week, we try to offer material for people at different levels. Just you're like, I don't want to have to think about this. Great, you can use the default image. It's got like
It's got
tons and
everything
tons
on
of-
it.
like, it's souped up. It's a Cadillac. Almost certainly, it's got everything. If there's anything missing, I can add it. But other of you are like, hey, how do data scientists work out this reproducibility problem? How do they work on a repo, which is all the collection of files, and make sure when somebody else goes to that, they're gonna have the right environment? Because, right, they're not gonna have PyRocket geospatial, right? Some other person, and you are seeing now, oh, this is how working data scientists solve this problem for collaborating. So you don't have to do this at the Hack Week, but there are a group of you who want to learn this next step for reproducibility.
Yep. Thank you. That is a good summary, for sure. And I like Pixi because Alex turned me onto it last year, and now I've used it as my production workflow for a year. So now it seems like I couldn't do it a different way. But I've also spent many years bleeding doing system administration, so, you know. So I'm gonna reload this. Oops. Yeah, go ahead.
Yeah, does it pull the package from GitHub or from Honda or just like any environment that's available? Just
It'll pull by default from ContForge and PyPy. But you can, any Conda channel, or any PyPy Powell, server, can be a source. And you can mix and match, combine them. Feel like
Yeah, we should wrap.
last year, we included like Biocon,
Yeah, that's fine.
channel as well.
does it have power to
I'm running into an annoying bug anyway, so.
does it have specific power to give it packages?
Generally, you're better off trying to pull from ContForge. It's more explicit about all the other dependencies that package might than PyPy will, or at least for the greater environment. Like PyPy will often say, install GDAL on your own. Good luck. ContForge does that for you.
All right, so I think, I apologize, my live demo did not work as I was planning. And we've already burned up a lot of time on this topic. So I'm gonna stop here. I also am going to load this tutorial into the tutorials. That's another thing I haven't done. I have it from last year. I need to move it into this year's branch. If you're interested, you can download it and play around with it, or I can help you. As you guys get into these issues where you're trying to add something, we should just do it on the fly. It's better than me just talking at you. So I'm gonna stop there. One of the other things I was gonna point out is that in the tutorial, I did write up in here, there's a bunch of links to reading about package managers, that if you haven't run into this problem and you stay in doing data science work, you will. So here's some resources to go read when you get really frustrated, because it can be really frustrating. So don't worry, someone will help you figure it out. And then also, these things are a little bit out of date from last year, but I'll update them. So with that, I think I'm gonna stop here and we're gonna talk about projects, right?
Yes.